So you can guys go in this website anaconda.com. Okay, or maybe there will be, you need to on the download page will, if this page didn't came, maybe some other kind of page you can get, like uh, pricing and all those kind of stuff. Just go to the Google and search Anaconda download. Okay. Download for Windows. If you have a Mac, then go for your Mac. No issues. Then if you have a latest, like more advanced architect in your system, like 64-bit, go for a 64-bit. Here in your Anaconda distribution, go this Anaconda distribution and you will see this download button. Okay, for any system, either if you use Linux, go for this one. If you Mac or even Windows. Okay, the standard is 64-bit. If you do not have like downloaded and it will start downloading in your system, then after downloading, if you completely download it, then there will be two things you can see. One is Anaconda Navigator and Anaconda PowerShell prompt. If you belong from any computer science background, you will already have an idea of what is a terminal. Okay, how you can use that. This is this PowerShell prompt is nothing but the terminal that Anaconda uses. Okay. Like your Windows system has a terminal, that is when you just command it for run and it will came out, like if you run like cmd and your command prompt came out, and you can use any command based input to get the desired output from your system, like creating new folder and all those kind of things, which things you are not usually do in your UI base. Okay, you can same right click and create a new folder, or maybe you can properly command it to create a new folder. It's accordingly to you. But the advanced people who are more into this CS world and more into the coding world, you will know that people will majorly use the Linux system where the command-based work are more prominent. So this is nothing but the terminal. The same thing is the terminal for your Anaconda file. So that's called Anaconda prompt. Okay, this is the Anaconda prompt. Then either where you can start like opening Jupyter, or maybe start your Python. Okay. And this prompt, there is one called in this, you can see in this bracket, there is called the base is nothing but, you may know that in your system when you install something, you can access at every part of your system. Each every part means this automatically created one environment, that is a global environment. Okay, suppose you installed your when you install your Python in your system, you can see, you can command it any Python syntax from your terminal, like I can open cmd, you can see, and if I want to run Python in my command prompt, I can just simply write Python, because Python is already installed in my system, just Python, and now my Python is currently running. If you did not install Python in your system, you can just go here, like Python for Windows or any system, and start downloading the latest part. Okay, it's not necessary, because as we along majorly work on the Anaconda prompt, so it's not required. But yes, definitely for your uh, purpose of your project and all, if you need to do any project and for your purpose, sometimes you require the Python library to install in your system, and that time you have to install it. Okay, so definitely when you created this environment, okay, it always exists for a global one. So I can, as you can see, I already type here, here as type Python, and it's already start running the Python already. Like I can uh, write Python syntax like print, say suppose um, 2 days plus. Okay, and I can enter, it will print that, because it's something with the Python syntax and it is properly working here. Okay, so this is as I can use at each and every corner of my system, so it can access globally. Now Same things when we install Anaconda by automatically create one environment for them. This environment where automatically your Anaconda supports some additional libraries that you may require for your analytical and the data science career, or maybe some visualization career. So automatically it provided to you, so you did not have to install anything again, or maybe you did not have to face those installation issues and all those kinds of things. To avoid those things, already provided by this Anaconda. So as when you suppose you are working with one library called NumPy, and you have to, when you install Python in your system, you have to manually install NumPy in your Python library when you install that. But when you install Anaconda automatically provided those libraries, so you may not need to install again. Okay. So this is the concept of the environment that people used to do. And when you would start working with a real-time work, real-time project, based on this project requirement, there will be some libraries that you need to work on. Okay, maybe some version of the library you need to work on. And that time you always, it's a good way to create your one virtual environment. Okay, so virtual environment, nothing but for in one corner of your system, you can install for a particular path, you can create one environment where you install all those libraries that you need for your project and all kind of work. So it will not bother to your global one, or whatever you install in your global one, it will not bother to your virtual one. It's a big concept. If you need, we'll discuss in some other classes or maybe some additional classes, those virtual environment, how you can create it. There are some tons of way to create it, but majorly when you work with the Anaconda automatically provided one environment. So if I some library, if you install like pip install and some library name, I'm not installing anything. I'm just giving example. Okay. Maybe some library. Okay. Some library name, and that time it will install to only in your Anaconda environment. This base environment, it will not bother, or it will not affect in any other libraries in your global plan. So that's how we used in general in libraries, how we install as a professional part. But most of the time, people will, even in the current industry, in the top industry, most of the time people won't ask you to like do such kind of create the virtual environment. It's for our purposes as the good way how we empathize our libraries and works. Okay, so it will saves more time. It will help us to get less bugs. Yeah, those kind of things. Okay. So if you from CS background, I guess you already know about it. If you are not from CS background, then those things completely may be new. I already discussed in my other classes. Those people already know how to create the environment and all. If you guys need those kind of libraries, then ask the management people. They can provide those things. Or maybe if you need some kind of requirement of classes, then let Sunit sir know. Then I will discuss about it. Any plan to do accordingly. Okay. So this is you installed in your environment. Then Anaconda, after you install your Anaconda, you can just search Anaconda here, Anaconda Navigator. It will automatically came. If it doesn't came, you can just in your prompt you can just start command here like Anaconda, or maybe Jupyter Notebook, the most common that will work, and it will directly open to your same library. Okay. So why Anaconda Navigator takes some spaces, because it automatically provide some other kind of tools and libraries that you may need. Okay. The thing is, sometimes as you may know, some of you already installed PyCharm and VS Code in your system. Okay. And before installing this VS Code and the PyCharm, when you install these two things also can use your global environment, or maybe you can create a virtual environment using those kind of things. Okay. But most of the time, because those are nothing but a simple your code editor, so most of the time as a by default they will directly take your global environment. Okay. But when you use here your VS Code or PyCharm, those tools, then definitely those things will start working on your Anaconda environment. Okay, so all the Anaconda libraries that already provided to you, you can also use when you open this code editor, right? And there are some like R Studio, sometimes some for some particular analysis when you need some basic R library, R functionalities, okay, some kind of like some recommend when you build some recommendation system, okay, some kind on some part of the statistical analysis, sometimes you may not need to use R Studio. First later is based on our user work, so that time we will consider. But the most of the time, we you can see that for the 99% of the time we will majorly use the Python. Okay. Then as we most of the time use the Jupyter notebook, okay, and the current generation, if you see in the current DS trend, the people will majorly start using developing more in the Jupyter Lab, because Jupyter Lab has the much newer functionalities when you use Jupyter Lab. But I always suggest that first use Jupyter Notebook, because first it will take a little bit time, 1 week or 2 week to habituate those basic functionalities. Okay, so shortcut commands and all. If you habituated those kind of parts, then definitely if you proceed to the new part on this Jupyter Notebook, it will be more helpful. You can launch here Jupyter Notebook and it will start launching. You can directly command it to the Jupyter Notebook, then it will work. Here, the system when which part in your Jupyter Notebook install, those libraries are presented here. Okay, and how much you will create, it will start creating the new file. Okay, now after I install that file, suppose you want to start working on it, just came here and create new and your Python kernel, and it will start. You can see all your kernel is present, and you can start writing all of your Python codes here. Okay. And this is one way to use that. You can install in your system. If you guys face any problem, then let me know. Next, if you don't have to use, means if you have a low end PC and there will be some times, because at least you need a more than a 4 GB of RAM to process fastly when you write any code here. Okay, because simple, if you write simple code like print hello world or simple basic function, okay, it will work. But when you definitely import a large data set here, okay, using suppose like, don't do that, please. So, where was it? So when you import libraries like import pandas as PD, and then when you imported that thing, this processing time you can see, because I have very faster memory of my system, that's why uh, it easily installed and easily run. But if you have a lesser RAM, then definitely it will take much time. Okay, and the for the major thing, it will take times. Most of the spaces on your RAM when we start processing. Okay, like import new data. Okay, say pd dot read underscore. Suppose you are porting some data as from the CSV files and read underscore CSV, those kind of things, it will take much time when you have the lesser. And for that, definitely I will suggest you, if you don't have to use the Jupyter Notebook, you can go for the Google Colab. Just search here and for Google Colab, open that Colab. It will take little bit time because each and everything it will working on your cloud platform. But some, if you guys use some basic cloud platform, then you already know, like AWS or Azure server, some new notebook you can search, or maybe you can create, because it's automatically uploaded to your drive and you can accessible each and every file from your drive. Okay, the say interface is same, the exact shortcut key that you will use for your Jupyter notebook also the same. Okay, so you don't have to worry. Just suppose there, if there is no connection will not there, so just connect it. If it's not there, as it's automatically connected when you have a good internet connection, it's not required a faster internet connection. But if you have a decent amount of internet connection, then it will start working on. Okay. The exact same interface, like creating your file, open, upload. If you have some IPv1b file in your system and you want to upload to your Colab, just click here and click upload notebook, and you can upload it here, upload the entire IPv1b file to your Google Colab. Okay, you can also copy from your drive or use your Git file. Okay, if you want to Git and your repose to your GitHub repository. That time you can directly a copy, save a copy to your Git file. Hmm. You can also download it, and download always definitely download most of the time in the .ipynb file, because those are the exact Python kernel that support in your Jupyter notebook and your Colab. And most of the time Jupyter notebook use the IPynb file. When you only used a single code in your single, or maybe a better say single cell in your system, that time you can store in your .py, because this key, this one cell, like this one, if I remove this one cell is nothing but a single cell that represents a code editor of your Python. So when you only use a single cell, that means the entire cell document will be in your single file. That time you can run, like suppose some modules you can, or some function you can create. That time you can store or download it as your .py file. Otherwise, most of the time we generally use as your .ipynb file. And you can also create, save, like code, text, each every kind of things you can do. Okay, like if you want to remove that cell, there is some answer like remove or delete. Yes, you can delete. You can see the shortcuts is also visible. Each and every hints it already represented when you use those cells. Okay, some settings like some kind of changes the triggers and all those kind of things. For now, it's not necessary. If you're interested, you can go those kind of things. But this is good. Pro is nothing but Pro only provide you the more functionalities and the more RAM and the disk space, nothing else. You can do each and everything within the free time. Okay, if I change the editor and the site, those kind of things are there. It's not much necessary. And after you finish everything, it automatically save to your drive. If you want to, you can rename it. The same things that you use in a Jupyter notebook, and you can also download and upload it. Okay. So either you use Colab, or if you have a good NPC, then when we was a decent NPC, then you can go for your Jupyter notebook. It's not much bother, as long you are okay with it. Okay. So for those who are not, who did not install it properly in your Anaconda file from your system. Okay, and then start learning the basic Python and all from those, all those parts. Okay, so today I will mostly go for the start with the first sessions of your data science and the data science fundamentals, where I will start as the basic of the statistical concept and go accordingly. When we will need those code parts, then we will go as well. Okay, so till now I guess everything is clear. If you guys has any question, you can ask, or else I will proceed to the next. So for now, you don't have to create any virtual environment and all. You can, if you want to learn, you can study those kind of parts. But as if for a global part or the basic Anaconda environment, we can still easily work on for the further process. Okay. Next, we'll start the basic fundamentals of a data science. Okay, like how each and every, what is the core meaning of the data science, how the career will, a daily life of a data science professional do. Okay, even when you will be become a data scientist or maybe analytics, data analyst or maybe business analyst, maybe system architect, maybe data engineer. Okay, what will be your exact career goal? That what things you need to do. So we'll discuss. Then later on we'll go for the basic on the statistical fundamentals. Where for today I will try to at least finish the part until the central tendency and the measure of dispersion. Okay. Then for the next class we will discuss accordingly. Okay. So let's clear that part. My screen is visible, right?
Yes, sir.
Okay. So if I ask you that what is data science or what is data science? What is the first thing triggers in your mind? Not the data science, I better ask you what is AI? What is artificial intelligence? You don't have to say any definition. You can just say what things that triggers in your mind that when you learn the word about AI or the artificial intelligence. Anyone can try. Don't have to think much. Just what comes in your mind if I ask about what is the artificial intelligence. Think it's simple. Just tell what is the artificial intelligence. Ramakanto, are you there?
It is a technology.
Sir,
Artificial intelligence is a
like as
technology. Yes.
like as human intelligence, it basically controlled by another technical part of.
Much better. Anything else?
AI means artificial intelligence that is a technical part and
Hmm. Okay. So as the Ramakant has told that some part of his training is definitely correct. That you can see by the name of the artificial intelligence means the intelligence as a human brain. What is the produce? The main thing we produce is the intelligence. Okay, based on the intelligence, we'll do all kinds of activities. Okay, either if you solve a basic Sudoku puzzle, or maybe go to your school, or anything, that's nothing but came from your intelligence because you already have aware those kind of things, or maybe you need, or maybe require. Your brain already achieved those parts. The intelligence is already received. This is nothing but the proper part of your brain. The same replica, the core part of your brain, when we will not do any human behavior, when you artificially create this behavior, that part you can call it, yes, nothing but an artificial intelligence. Okay. So we enables any kind of machines okay, to think without any human intelligence or maybe any human intervention. Okay, then all those machines will able to take its start taking its own decisions. Okay, this is nothing but our AI technique. Okay, where machine tries or maybe start trying to mimic the human behavior. You may know that all first major AI revolution will start by the IBM peoples. Okay, maybe in 50s or 60s, those kind of time. Okay, and if I remember, there is this guy name is some John McCarthy or something like that. That guy first give his first input about AI, and then further research progress was going on, and it's more developed and developed. And currently, you can see the based on the current trend of Chat GPT and the most of the uh, extreme advanced model that machine can do kind of. So it start already from a very long process while the all those research and everything goes on, and now modern we can have those kind of new fundamentals and all kind of ideas and the models that we will use for our daily purpose to get our desired output. Because AI invented when you can see one of the side part that AI definitely reduce, that's the human labor. Okay, where in the part of the human labor, when we can definitely use some kind of machinery intelligence to just remove that human labor and then start using any robots and for that. And it's if I give you the basic, as some people also say that the revolution, this current generation is the nothing but the revolution of this AI part. So the revolution, as you can see, when from this after the COVID part, when the Web3 introduced to us, okay, this generation you will see not only this 2023 but also in the more than 5 to 6 years how better and the fast progress that in human will already did in this AI part, rather comparatively all those 50 years or maybe 40 years of the history of this AI part. Okay. So everything we can do, every single part we can do is nothing but when you use the machine to use their intelligence, this is called and AI. Okay. So you can see that every global that part that we will work is nothing but our AI. Look, artificial intelligence. And from the artificial intelligence, there is one subject you can call it. Okay. One subset or maybe the subject that we measure with. This is nothing but the machine learning. When it part, machine learning, we definitely use some basic statistical tools and the statistical models to explore those data and understand about the particular data, and maybe sometimes some desired output you may require that can give you. So for one part of your AI career, there you can see there is one subset you can say as a machine learning. Okay. So machine when comes to machine learning is nothing but you can simply call it a subset of AI. Okay. And more if I give you the more general definition, then definitely we can call it that a computer program. Okay. Definitely it will start learning from an experience to do some task. Okay. So when start a machine from the learning from a basic of your role, then we can call it as your machine learning. Okay, that's a very simple definition. Really. So in this machine learning, there are majorly three part of the machine learning that we may know. One is the supervised learning and the unsupervised learning and non-supervised learning. The major three part of know, but some other sub part is like semi-supervised learning and reinforcement learning. Those parts are there. Those are the nothing but other parts of the machine learning. Okay. Now, in this machine learning part, okay, when it start developing, some advancement reduce when all those models start working as the human brain. Okay, when those things maybe particular that kind inspired by the human brain, okay, and start working with like creating the exact replica of our neural system, that's the neural network. Okay, that time we introduced the advanced part and we called it as our deep learning. So deep learning is nothing but majorly when the exactly neural type that every nodes and from the nodes that connection will make. Okay, so connection will make and the exact replica behavior of the human will start introducing. That time we introduce the methods of the deep learning. Okay, machine learning when we can simply use any data it will this, then we can start any model and we can get any out. Okay, get the output or maybe any required result that we will that part we can do using the machine learning. But then the deep line we start doing the same, but that time we majorly use the replica of the human nervous system. Right? We created the neural network. That's a major part of the deep learning, and then we get the desired output. So, okay, what will happen? The model will become more efficient. Okay, the learning part of our model become more efficient. Okay, the error or maybe the efficiency of your model become much better when you use the simple basic statistical modeling. Great. So this is a basic nothing but your entire career as a AI. Okay. Now, data science is nothing but all each and everything is subset that part used for our data science career. Where in this data science is nothing but we simply use the basic data via data exploration and all those kind of things. But each and every technique you can use for your data science career, and for that we use the all kinds of data and all kind of models and the tools that provided by the AI to get our basic desired output. Okay, so if I give you the example like the analysis or maybe the calculation of some kind of basic data related project, they suppose some business trade off or maybe some stock analysis prediction. So all those kind of work definitely if we start using the basic statistical models and all, that time it will be much helpful and the much efficient when we get the desired result rather than just simply created or build some mathematical computation by own. So that's why data science start using all those tools and the model that are provided each and everything from this AI part, and then it will become much help. Okay, so catch all those everything like your machine learning, data learning, deep learning. Okay, another data learning, data mining, all those analytical part it will start getting, and also the basic statistical tool like probability statistics, okay, and then estimation, hypothesis testing, ANOVA, okay, correlations. So data science will nothing but become first you understand the problems. Okay, first definitely understand the business problem. I'm using a shortcut to represent. Okay, where you know the what are the exact project work that we need to do. Okay, so what will be your business purpose that we need to do. When we understand the business problem, then the major part that came into the bigger picture, that's called collecting the data. Okay, and the data collection is the, I will say you the data collection is the most important part comparatively building a model. Model building is far easy than collect the data, because data collection is nothing but based on your expertise, based from your knowledge, which data you will start working on. It's not like for your learning purpose, you will see that ready-made data. You know that I need to predict some house price and the exactly uh, perimeter of your houses and what is the prices, those value as work on. You will always get the data as a raw format, and from that you need to extract your data. Okay, so data collection is the far important, and how you will collect it either I will get one for how people will do that those things, but their data collection part is completely based on your own. Like you are open to word, and from that you have to just put. If I give you the example, like suppose you are working on a project, like some, say suppose some literacy circle, you want to find out what are the which district of our India has the least literacy circle, and for that you know that how much you have to explore, like for every each and every state, each and every district, from their part you have to need to collect the data and all kind those kind of things. Or maybe you can use some kind of advanced technique to explore all those kind of data and all. Okay, so that's why data collection is a huge important things to do, because after we collect the data, the major part will become a data collection, and then major part will come is the data processing, okay, data pre-processing and those kind of part, or maybe data cleaning. Okay, where we do all those techniques to need a proper structured data that required to our models. That time we do all those kind of statistical operations we will do in this data processing, either the outlier treatment, missing data values. Okay, we need to plot some graphs. Okay, we need to do some basic EDA, okay, to get the basic accuracy, basically presentation. So these two things are the major, I will say major important part than rather than the building models. So because if we definitely have a really good confidence about those things, then if you have this confident data, then you can simply nothing but you will create your building models. Okay, building machine learning models. And building machine learning models, there will be some techniques that we will do definitely, because basically not the only work of us is simply building the machine learning models, but apart from it, we need to check the accuracy. Okay, maybe some treatment we need to do. So all those kind of this kind of parts definitely is nothing but a circular process. Okay, maybe some kind of discrepancy you may found. Okay, then you need definitely even go to the data processing part, or maybe the data collection part. Some kind of new work you may need to do. Okay. So this is nothing but an entire circular process. These things are due. Yeah, these three stages. Because after you finish those kind of work, then nothing but there is the only part is come to the insight. In the insight, you may know that what is the exact idea that you want to receive. Either you will receive it or not, or maybe you don't know about the idea. You will only start conclusion based from the model, out of the model, the prediction, all those kind of things. The each and every knowledge that we need to receive, that part we will do is this is the insight. Okay, then you if you have to use, then you will go for create host your models. Okay, some production purpose you may send your model, those kind of things we will do. Okay, so this is nothing but a data, how exactly the clear picture of a data science work. Clear. Now if I work, uh, if I want to say you that in your career, what is the clear of your data science projects work? Okay, if you are a data scientist or maybe some kind of analyst, or what if a proper data science project, how the project will implement in your society of your definitely either product company or maybe client based company. Okay, so when some ideas will start, okay, maybe so suppose you receive a business idea, the business idea from which people you will receive. First you will receive either from, if you are working from a product sector, then there will be some kind of maybe domain expert. Okay. Some domain experts, and maybe there will be some stakeholders. So these two people, either the domain is or the stakeholders. Okay, maybe some client people will be there, some client XYZ, some client people will be there, maybe some product side people will be there. We'll start discussing about the exact, a clear idea of your analytical project, and they will definitely, the domain people, okay, they will definitely start discussing with the business analyst. Okay, the first start working will be the business analyst. Okay, they will discuss again. It will do the circle process where domain people give you the idea, okay, and you are the BA peoples, you know. Okay, maybe some other requirement you may need to know. You will then again discuss with the domain peoples. Okay, maybe the stakeholders. They will again give you some basic idea. So all those parts you will start discussing with the either your domain peoples or a business owners. Okay, and then there will definitely some requirements you will understand that for your project which requirement you need to do. Okay, you definitely note down. Yeah, you definitely note down all those requirements that you need to do. And then as when you have a clear idea of which what things you need to do, you will definitely start discussing with your data analyst. Okay, the first exact start working is your data analyst. Okay, now business analyst people start discussing with this data analyst people, and they will discuss about which data they will start working on. Okay, from where you will get the data. Either you need to create one API, or maybe you need to get from a third party, or maybe some you need to scrape your data. Okay, maybe some internal data will be there in your client base. They can provide the data. So from that requirement that we receive, okay, from the requirement we receive, they will start discussing about the data. So nothing, clear picture is the data. Clear. Either your data come from your internal source, or maybe it will come from your third party. Okay, it will maybe come from your some private source. Okay, they will discuss, and also they will discuss about how the collect the data. Either you need to create the API. Okay, maybe some basic analysis you will do to get the data. Okay, maybe some scraping you need to do, web scraping you need to do. Yeah, those kind of part they will discuss. And until they will have the clear picture of which data they need to get, all the circular process will start working on, from your data analyst to business analyst to the domain people, and then from domain to business analyst to data DMP. Even direct the stake, those people can definitely discuss with the data analyst also. And not only the data analyst, but also the your data science people also can stay there. Okay, they can be some supervised upwards. Okay. They maybe can give some guides, because DS already have the better experience than the DA people. So obviously those kind of discussion are. So when we have then clear data of the data and everything, then the next people that we need to work on, that is called data engineer. Okay. Data engineer is nothing but their major part will be the exactly collect those data. Okay. They will collect those data. Okay. Collected data, and definitely they will store it. Okay. They will store. They will store in some, maybe some RDBMS they will already have, or some RDBMS. Okay. Or maybe Node, either they will use SQL or maybe no SQL. It definitely depends upon the industry and the data that we receive, and definitely it will of course have the major impact of the which project that we will be working on. Okay, either if it SQL or MongoDB. Okay, or maybe there is a one good way, and the most of the time people will do is they not only store their RDBMS system, okay, for the major in the client sector, they will definitely use some cloud-based architecture. Okay, maybe they will use AWS or maybe Azure. Okay, any cloud based platforms they will use, and they will store it there. Okay, so from now part, we have the all clear idea about that which data we need to work on. We have the clear idea about that what are the requirements. Okay, from now it's stable. It may not change, but maybe some after some analysis, that requirement and the some business ideas may change. Okay, so from now part we have the collected data, and after the part there will be one team that they will supervise, that is called a data architect. Data architect is nothing but their work will be scale your data. Data is scale means, suppose you are doing one project on the weather basis. Okay, so from the weather basis, suppose you have to store the data, the daily temperature of a particular timeline, say 10 a.m. or 10 p.m. Those two timeline of the exact temperature you need to store. So data engineer people already store the data. Now data architect will do, suppose they will only need the stored data in that only in the Kelvin format. So all the scaling part you can say, the which frequency the data should be collected, those things will be discussing with the data architect. Okay, or the which scale or the which frequency data should be taken and the so they will discuss. Okay, so either the frequency or the scaling. Okay, now these things may repeat it. Each and every discussion they can repeat with those people. There will be the some changes, and from the requirement may be changed, the data collection will change. It will take a lot of time. For a real-time project, you can see on an average more than a 6 and 8 months it will take to nothing but just do those kind of steps. And then the next part will be after we have everything. Now let's start with the basic data processing. Okay. Again, the next picture will come with our data analyst and data scientist. Okay, in some industry, business analysts also do those kind of work. Okay, some small startup where there is the lesser amount of people, those people will do. So now they are the bigger role is scale. Okay. They will work on the all those data pre-processing, data cleaning, okay, data scaling, yeah, all those kind of things. Treatment like missing value treatment, basic EDA, okay, feature scaling, normalize your data. If they will check the distribution, maybe they will check the outliers. If there is some remove of those data, those part of start working on this level of data analyst and the data scientist. Okay, they will do all those part. Okay, after doing everything, they do the feature scaling and all. Okay, they will start build one BI dashboard. Okay, it's necessary to build one BI dashboard, and then this dashboard they will again goes to our analyst, business analyst, and they will definitely discuss that this is the outcome of the basic data processing of all. If there is any required or any changes or maybe any requirement is scale, then we'll do that. Otherwise, we'll proceed to the model. So this thing is further repeating. As I told you, each and every step is nothing but repeating with each and every request. And then the next step after finish each and everything, they will nothing but create they will nothing but create models. they will create models. So this part you can say a project that more than 30 or maybe 30 or 40%, the max. The in an entire project, the 30 and 40% completed when she is nothing but after each and everything created on models. Okay. So after creating models, definitely some checking the accuracy. Okay. Okay, model creation. Maybe if the accuracy is not matched, then again there will be discussion with the data people, some which frequency data they needed. Okay, some parameter tuning if you needed. Those kind of parts they will do, and each and everything will be discussed accordingly. After they finish each and everything, the data, the model is properly built, model is performing well. Okay, then they definitely do is deploy your model. Okay. After that, there is nothing but model deployment. Okay, your final model is here and you will start for model development. And for the model deployment, there is the work of your DevOps people. Okay, the DevOps people will come picture. They will nothing but deploy your model at which frequency you will told, and they will nothing but deploy your model. Okay, on if you're either AWS system or your Azure system. Okay, or maybe their own architect. Okay, own system, private architect. This definitely depends upon the each and every organization, and they will nothing but deploy your model. Okay. Then, which for that some knowledge you needed, like some web domain like either Django or Flask. Flask is the major time the Python people will use. Okay, maybe you need to know some kind of ideas of the web development people. Okay, some domain idea you may require. Okay, sometimes some Express and Node.js idea you may require, but it's definitely depends upon the requirement of the project, and the learning will definitely depends upon as along with that requirement. Yeah. Sometimes you need to learn about the basic EC2 syntaxes and the creating the bucket in your database. And then after you deploy your model, that time the start beginning of a new phase to repeat each and everything of the entire process. Okay, means after you developed here, the developed the model, then nothing but then after developing model, then again you will receive the new data. Okay, the new data is received. New data you do all those part, which is scaling, missing value. Okay, all those data processing part. We have the model ready. We based on this model, we'll see the performance. Okay, if the performance is decline, then we'll definitely check some ideas like your parameter tuning. Okay, if there is requirement of parameter tuning. Okay, some trade-off, bias and variance trade-off. Okay, so it's nothing but a circular process, and it start from going and going. Okay, once it's developed and deployed, then it will start working for endlessly until and unless if there is any changes to your required. Okay, maybe any upgradation is required for your model, then you also do accordingly. So that's how the entire process of a single-handed data science project work is how much those people. So you will know that sometimes as people may use for after in this part in here, there will be some BI peoples are there. Okay, BI analysts are there. Will nothing but create the dashboard from each and every step, either from this step or maybe data engine this step. they will nothing but create and report it. Okay, report it to those analyst, business analyst people and the domain expert people, and they will do that maybe. Otherwise, because most of the time that only the technical people have that idea to create that exact those modules and technical part, okay, analysis part. The business people most of the time does not have the idea what are the pandas code you will write. They only have that idea that either you will have received the exact positive trend line growth or the negative trend line growth. And then based on this requirement, they will start to give you the more to do work, like which things you need to do, which improvement you need to do, okay, which tune you need to do, those kind of. So how many like in the entire project, there will be definitely some major work with the business analyst, data analyst, and the data science, and also some other work like your data engineer people, data architect, and your BI expert people, and definitely some domain expert, okay, or maybe stakeholders. So this is it, and each and everything when a lead data scientist, okay, or maybe senior data scientist or data scientist or any analytical manager, okay, those people have the clear idea of each and every step, how each and everything is work, so they will monitor, those people will monitor each and every step of your data science project. So it's clear, I guess, how a data science project work. Do you have any question? You can unmute and you can ask me. Okay, you do not have to chat always. Now, in that, this is the basic idea of a DS, data science principle. Okay. Now, as you know that basic, first you need to understand the data. Okay, because after you understand the data, then you will go in the modeling part. Okay. So machine learning is nothing but we'll use the statistical modeling, okay, the statistical tools and technique to use this modeling. But for that, we definitely used the statistic to do the basic exploration of our data. Okay. So as I can say you that for our each and every part, it's not necessary. Even if I give one example, uh, suppose a prediction of our house price. Okay. So for the simple techniques, it's not necessarily to you need to use all those advanced part and all those kind of things. So all definitely sometimes a basic linear regression model will work. Okay. In nowadays, linear regression will be teaching in about 8th grade or 9th grade people. Okay. Some basic data you will receive. You can just plot the data. Okay. Suppose you will get the base fitting line and you can get some for this area of requirement. I need to start pricing, keeping the pricing of this amount. It definitely depends upon if the more efficient you need to make, then you will start upgrading to it. Okay. Now, and also one more thing I need to say is each and everything that we start working is nothing but our mathematics. Okay. When mathematics comes with a new intelligence, okay, then that part you can say is nothing else our statistic games. Okay. So for that you can buy single-handedly if you do. You did not need to know all those kind of machine learning or maybe say Python, narrow. Do you really require? No. Then why those things came into the bigger picture? Because the same things we do using the human mind. Okay, if we take help from these tools and techniques, then definitely it will reduce a lot and lot of time most of the time. sometimes a project you can finish within a single year if you do single-handedly. You are not allowed because our sometimes human brain is not capable enough to remember each and every aspect of the data we will receive, and all those mathematical computation will do. Okay. Because the basic statistic and our statistic, probability, and the calculus. This is the major three things that will start working with our machine learning. Okay. So where was I? Yes. So okay. So for understanding the data, we need to definitely understand the basic idea of the statistics. Okay, some basic idea of understanding the data part. Then we can go along and move into our machine learning. Okay. Now next is in your data science or maybe analytics, there is in our general purpose, there is three types of analytics that we generally follow. Okay. One is called descriptive analytics. Okay. We'll discuss what descriptive. One is called your predictive, and another is called your prescriptive. For your descriptive analytics, it definitely tells you about when you receive the data, it definitely tells about what happened in your past. Okay. This is the description you will receive from the data, that what is the past it will happen, and you will start working along to the further. This part of work definitely considered in your descriptive analytics. In your predictive part, as from the name you can understand that we'll definitely do what will happen in future. Okay. This is we majorly do in the predictive part. Based on the data we have, based on the past experience, we need to understand what is the future work will be do. Okay. And for the prescriptive part, we know that from the prediction, okay, or maybe we will say based on the prediction we did, now what should we do the first year? Okay, you know from the predictive analytics, we know what will happen in the future. Now, as the what part will know, we know the based on, I will better say based on the understanding or maybe prediction. Based on the prediction, we know what will happen. Now, what should we do? What is the new work? Okay. This part comes in your prescriptive analytics. Okay. So this is the part I'm not going to much deeper because it's not necessary. As along we'll go into the statistical part, then accordingly we'll discuss from point to point. Okay, you will understand each and everything. Okay, like what is our sale? Maybe some sales record we need to do. Okay, some review of our Adidas sale we know in that Kolkata region. If there is some data that you already know, some kind of sales you did, now you can predict that what will be the after that post-COVID part, what will happen in the past, and after the post-COVID part, what about with all the sentiment and the market analysis, and then we will know that what will be the next two projection of our sales part from this predictive analytics, and then from our predictive analytics, we will need to start working on which things we need to do, okay, which optimization we need to do. Okay. Those are the thing, but we entirely created a basic analytical background. Okay. What is the requirement in the business part? Okay. So from this business understanding, okay, for within the understand the problem, we'll do from the data understanding. From the data understanding we will have, then we'll start doing the data preparation for data collecting, data processing, treatment, all those kind of things. Then we'll start creating the models. Okay, models if we do, then we'll start doing the evaluation of our models. So it will have some kind of accuracy and all. If there is some changes, then we'll again go back to our business understanding and repeat each and every step. Okay, and then later part, when we have everything finished, then we'll do your deployment. Okay. So for the data understanding part, we definitely have to consider like what are the availability of our data we have. Okay, basic question. The when you receive the data, basic question you can ask what is the availability of our data. Okay, you may ask what is the exact the quality of your data that we receive. Okay, you may ask what is the granularity of your data that we receive. Okay, maybe the frequency of the data that we have. Those are also the basic question a business analyst people can ask. Okay. And from that, then they will start with the data understanding. Like that question and answer, and will start working like maybe you are. If I give you the example of an army, that when the kid play with the sandbox, as you some people may see when the sandbox some kids are playing, they know that for if you use any container to fill that sand, they know the how much sand it will need to fill that container. Okay, so this is in general, it implies with the sandbox example. Okay, so as we know, then the exact amount of sand we feed to this element to create maybe some sandcastle and all. Clear. In the previously, before the evolution of the Python library, the R part will introduce. Okay, maybe R and SPSS or maybe some other people use the MATLAB and the Octave back then, but after introducing of these tools and libraries by the Python, because most of the time the automatically they provided so many things in your libraries. Okay, so many tune and all automatically it started tuning those parts. Then it is definitely help us to create that our new models. Okay, so that's why R Studio or SPSS, MATLAB, Octave, those things definitely use people, but modern industries start definitely move towards your Python and the Python model, and definitely there will some other parts like for the one idea of your DBMS, either the SQL or the NoSQL, and one idea of what visualization, okay. Either BI. This you can do the visualization using the Python, okay, but advantage is if you use one BI tools, either it's a Power BI or the Tableau, because they provided some additional support and the features that definitely your visualization or maybe your basic dashboard will look more beautiful and more clear picture than we will be using this Python. Mhm. Now this comes with the data. Mhm. Suppose data. If I ask you, what is data? If I ask you for a simple question, what is the data? Comes in your mind. Try it out.
Data means information.
Data means information. No, data doesn't mean information.
It is a raw fact.
Yes, data is nothing but a raw fact. Okay, I can tell you that today bowler take wickets. Okay, in a cricket match, bowler take wickets. It's an so if from that raw data, you can only do one simple information like it's an bowler friendly pitch, right? So data is nothing but a raw information. We did not know much about it. Okay. We can start building the context. Okay. You can start building the context from the data. Okay. You can ask questions, what happened? Okay. What is the purpose? What we received? Okay. So data is nothing but the collection of raw fact or the collection of anything. It could be anything. Okay. You can tell you like there is a there is 800 million subscription in Airtel network. Okay, you cannot do a judgment like okay 800 million means there is 1 million or 2 million more than the Geo network. Okay, or maybe you can say some data like there is 1.2 billion 1. 1.42 currently 1.42 billion people in India. That doesn't mean they in that information you can only know that yes, only India has 1.42 billion and nothing else. From that part, you can have a basic information. Okay. From that part, you have basic information, and in that sense, you will start building some question. If India has 1.42 billion of people, then why the 1.42 billion people is give the value as compared to the rest of the world? Okay. Okay. What is the aspect value of 1.42 billion people compared to the entire population of the China industry? And from that information, we have some meaningful information. Okay. Some meanings will be there. Okay. From that meanings, you can create some knowledgeable output. Okay. So based on the data, we definitely create some information. From that information, we can create some knowledge. So information is nothing but you can say one level ahead. After the data we will receive one level ahead process of your data, and from that part we can just simply nothing but do some meaningful operations. Okay, some meaningful operations. We can say like say suppose the Ranji finals, you can see that Bengal currently got into the Ranji final, right, in this year. So you do the one basic analysis and you will do that bowlers are definitely do well in the Eden Gardens, Kolkata. So you have a data set of the bowlers. So from the bowler data set, you can only know that bowler can take wickets, I mean much wickets. This is the only the major thing that you only know. From that raw data, you can do some meaningful start basic insights. Okay. Now from that from the data, you start doing some information. Let's suppose in there is 2 or 3 types of pitches are there. In which pitch, how many spin bowlers taking a wicket? How many first bowler taking a wicket? So from that raw context, you are doing some meaningful insights and you will creating some information. Okay. So from that information, you can create some knowledge like if in Bengal Ranji team has the good spinning people, the spin bowlers, then definitely it will help them to take more wickets on this as the pitch is turning because spin bowlers are taking much wicket the first bowler. So you can do some knowledgeable insight from this raw context of data to information to our knowledge. Okay. So this is the basic how entire a data and of the industry how the data insight will start work. Okay, we definitely as your work you will definitely have the raw context of your data. This is only you will receive. No, not a single person who will gives you the idea. You have that requirement. Okay, the requirement you know. Based on the requirement, you will have to start building your insight from the raw data, and from that you will start have to creating. Sorry, not the creating, using those statistical knowledge to create those insights. Okay, summarize all raw information and all each and everything you can do. Yeah. So data is nothing but your raw picture. Then we can get some context from that raw data that can be you can call it as a information, and from that information we can have some meaningful insights. Yeah, that's called the knowledge. Yeah. So one more thing is the data, most of the time the data we will see is nothing but a picture of the populations. Okay. As if I, but in general, most of the time the data is not called as a population, it's nothing but a sample. Why? Because suppose I'm giving an example in suppose the census of a data. Okay. Till now, till the census start from that day to the current one, you have the census data of India. Now you can say as the entire data you will receive or entire data you have, you can call it as a population, means the entire data. And from that population, you can create some samples because population is a huge data. If I want to give you one requirement that you need to find out that how many child marriages are there in all over the world. Okay. Now you will definitely not going to collect all those populations because all over the world is the entire population of your world. So are you able to do work with the entire population? You can do if you want, but definitely it will be hectic and it will be taking much time. It will not efficient. Okay. And your output will be not desired. Okay. So definitely working with the population is not the major idea, and most of the time we will not work with the population. We will definitely create the sample from the population. Clear? Now, the thing is, suppose the same example as I give you, that entire Sensex data. The entire Sensex data is, if I consider, suppose from this 1950, the Sensex is came out and we have the data, but is it really represent your population? If I ask you that from this 1950 we collected the census data, okay. Now you are calling it that this is nothing but a population of the census data of India, okay. But is it really represent your population data?
No, sir, totally not represent the population data.
Why?
Sir, it represents with population and another data too. No, that means the pricing high and the price level of the utilities.
No. Don't have to go for the price level. Okay. Just simple. You only have the age. Okay. That's age of that every sense when you do the Sensex. Sensex is nothing but no. Oh, okay. You did not understand. Sensex is not the market price. Okay. The stock, not the stock market index. Okay. Sensex
Oh,
is
okay,
I am
okay.
asking about that the when Indian government is counting the entire population's data. Okay. That's how I'm coming. So that's when Indian governments do the census, they counted the population and one parameter is the age. So if I ask you, is it the really the population data of the entire census that people receive or the data we have? Is it really a population data? Try it out. You have to think, otherwise, because each and every part of the statistic or the data analysis is nothing but how much insight that you will put. If you are not, if you not put those ideas or if you not think about it, then definitely when you receive the business problem, definitely it will create a problem. They create a much bother. That's why you can try whatever comes in your mind. The question is, when we suppose in Indian government is doing the survey or the census of an entire people that were lived in India and they have the data of Indian people name and their age. Now my point of view is it really represent that entire population of the census data?
Sir, it depends upon the manual survey, na?
Yes, manual survey. I'm asking, is it represent that entire population data or not?
Sir, I think so.
Actually, what happened is most of the time we see in the current world is nothing but a sample, not that entire population. Why? Because in that example, we are only considered the data from that 1950 to the current date. Okay. There are definitely people lived before 1950 that we are missing out. Okay. So we are doing nothing but a part of sample or maybe a sample from that entire population. Maybe people living since the earth and then all those human evolution happened. Okay. So most of the time, if I you one good example is suppose you are collecting the average height of a 18-year-old girl from across the world. Okay. So you can say, okay, now I have the all those data of the 18-year-old girl, the height data of 18-year-old girl. Now this is nothing but a population data of an height of 18-year-old girl. But there will be some people that already dead or passed out. The data will be missing. Okay, some unknown, some maybe in this survey there will be some missed your data. That part also is missing. So definitely, what if most of the time we do is nothing but a sample of the data. We'll start working on. Okay, as a our scenario. Okay, for our purpose, maybe some kind of mathematical computation you do. There will be some based on the formula you will do. But as of for our knowledge, most of the time we will do is nothing but most of the time we will receive is nothing but a sample of our data, and from that sample we definitely do estimate for that entire population. Okay, even you will see that all those archaeological, all the historical survey, how people will start to estimate each and everything that happened a way long before to the current date based on the data that will is in the current date. Because they will be nothing but collected the data, and from that sample data, they will be estimate those parameters. Okay. On the all those historical things we are seeing. Yes. So from the sample, there is I can give sampling part will came again for sure, but one thing you can see that most of the time people used to do is the stratified sampling. Okay, some other types of sampling ideas are also there, but the sampling techniques will definitely we will use most of the time the requirements we have. Okay. We'll came back again when the correlation part when we'll do this sampling, which sampling that we need to use. Okay. So one more thing you can understand that the major suppose there is 1 billion of data is there, you will only take 100 of it arbitrarily 100 data you will repeat. So there will be definitely some chances that some important value will be missing out. Okay. Now you increase the sample size to 1000. Yeah. Now in this 1000 of the data, you will definitely when the major some important part that missed here maybe some parameter you received here, some idea is received, or maybe some idea you received, but still there are some major idea that missed. So you again increase the sampling to maybe 1 lakh. And from our survey and analysis, we now get the idea that 1 lakh is a really good sample. Okay. So all those parts of the data in the sample, there is one major parameter that is different is the smaller in your sample size is definitely nothing but creates your larger the error. Okay, larger the error, or maybe you can say larger the chances of missing, larger the chances of missing good information. Okay, those things depends when you do the sampling technique that will use. There will definitely some techniques that will use. 3 and 4 types of technique most of the time we use. Either it's a stratified sampling, okay, maybe cluster sampling. If I give you one small idea, is suppose in 1 billion people, we will nothing but creating 10 cluster of that 1 billion people. Cluster is nothing but groups. Okay. Arbitrarily, we created 10 groups from their 1 billion people. Okay. From each groups, how many of represent 10 lakhs? Is it 10 lakhs or 100 lakhs? 100 lakhs or maybe 10 million.
100 crores.
Hmm. So from each and every 100 crore, we can only take, say, suppose 1,000 or maybe 10,000 of people. Okay, from each and every node, and this node should not be interrelated. Okay, it should be independent. So you can see if we do those kind of sampling, then there will be definitely some advantages. Okay, so some data when you do that, the data sample data is less, and it will not lead to our overfitting or maybe those kind of problems, and it will have the strong insights. Okay, this is one types of sampling that people use. Okay. There is other kind of sampling is nothing but the stratified sampling. Stratified sampling is when you do the clusters. Okay, in an uneven group, you do the cluster. From that, suppose this is your bigger cluster, this is your smaller cluster. We'll take big data from this bigger cluster and small data from the smaller cluster. Okay, then we'll create one sample. Uh, and the main rule is draw the more number of sample from the larger circle here, and the less number from the smaller circle, and we do the final sampling here. And this is nothing but called as stratified sampling. We'll definitely discuss all those sampling part in future when we start the correlation on those kind of things, and when idea about the estimation, the hypothesis testing, then it will be much helpful. This is done. Now next is, yes, this descriptive and the predictive analysis, that the major part in our for our statistical tools and strategy analysis. These two techniques, these analytical techniques are majorly used. Okay, and from the in the descriptive part, we nothing but definitely describing what is our data. Okay, we summarizing or maybe organize our data, and from this raw data to the process into the information. This part will definitely work on this descriptive part. Okay, from our, say, raw to get our information. Okay, this descriptive analytics. Okay. For that, definitely we will summarize or maybe describe the various number of facts. Okay, and the data is either it's a numerically or the category, graphically, categorically. Okay. And like they will be deriving some frequency. Okay, we'll see in the frequency diagram in today. There will be some percentage representation. Okay. There will be some mean, median, mode representation. Okay. Maybe some contingency table or cross tabular data representation we will do. So we'll get some basic idea. Okay, from the raw information. That's what we will do in this descriptive analytics. Okay. Descriptive statistics, no, that is descriptive statistics. Okay, in this descriptive analysis it will come, and next another part of statistic that we will do is the nothing but the inferential statistic, where we majorly do with this predictive part. Okay, when we'll start introduce the statistics there. So from their part, we'll nothing but some draw some interference. Okay, inference, not the interference, inference. Okay, some based on this population data from the sample data, we'll do like some testing of our data, like the hypothesis testing, some estimation. Okay, maybe we do all those, take the correlation. Okay, the correlation expert, then maybe some data forecasting and the explorer ADA part. Those kind of do all those major statistical tools we will use in the descriptive, sorry, in your inferential statistics. And major our statistical tools measure or statistic will definitely describe these two. Either it's a descriptive statistic or inferential statistic. If I create statement. So one is our say descriptive. Okay, descriptive statistic, and second is our inferential systems. In the descriptive statistic, what do we do? In definitely raw data to some get information, and in inferential statistic, we will do is we definitely draw some inference from the data. Okay, some understanding. Okay, that we will create. And that's why here all those techniques like correlation, then our hypothesis testing, okay, estimation, okay, central limit theorem, those kind of things came in the bigger picture in the inferential statistics. Okay, data forecasting, time series analysis, okay, some EDA part, okay, maybe some data mining part will come in the bigger picture here. All this part in the inference statistic. Then for our descriptive one, we'll definitely have some idea, like either some mean, median, okay, mode, understanding, okay, some frequency distribution, there's some maybe cumulative frequency distribution. Those are the pictures in games in the descriptive statistic. Now there is one important part that came as the different types of data. Okay, in the different types of data, people may miss out that only people will talk about the qualitative or the quantitative data, the numerical or the categorical part. Okay, but this is not only the single part. The data can be available to you based on the requirement. Is maybe in the different scenario. It is a really in the bigger picture. Okay, so if I create one tree-like structure, then it will be much helpful to you to understand. Okay, let's write. Let's write our types or data. Now, types of data. Okay. Now, types of data can be, we can define it based on so many parameters, not only just the simple qualitative data and the quantity data, the numerical category. This is not the two. The data, what if you only receive a time, one a simple time data? Okay, then how you can differentiate this time data in this qualitative or the quantitative, right? So first, the major parameter that will depend to different types of data is nothing but the source. Okay, the source of the data, from there that we will receive. So we can simply write say based on source, we can create some differentiation. So based on source, say there will definitely one is our, I'm writing P for nothing but primary source, and another is called our secondary source. What is, okay. Now primary source, if I ask you that primary, what is the primary data source that you can understand? The primary data source is nothing but when you know, okay, when you do something, you are doing the collection, you were collecting the data. I know the requirement, but I am do the much each and everything from my side, from my inside, and doing the data. So this is nothing but the picture came is the primary data source. Okay, I know the specific need, what do I need to do, and for that specific need, I will collect the data, or maybe whatever things I will do, I will get the data. This was the primary source, and that secondary source is nothing but when the data will be taken from the most available resources, okay, and for a different purposes. So you get one purpose of predicting the sales data. You will be collecting the market sales data of an hero motorcycle of the every quarter for since the last 10 years. So you know the specific scenario that you receive. You get the received data. You also get that data from some other part. Then you will create it some bigger picture. This is called as nothing but given into our secondary data. But in your primary data, when I know that I do the experimental studies, okay, I created one form and ask other people to fill the survey form. Okay. So I know things the specific in the exact specific thing that I need to do, and that part I will do or collect this data. This is nothing but a primary data source. Now, primary data source, you can tell you that primary data source can be differentiated into many part. Okay, one is we can call it experiment. Okay, experiment is nothing but when the experimental studies, when the variable of the interest are the first identified. Okay, we know that which factor are controlled in this data. As actively I am participating in this data to collect this data. Okay. Like say suppose in your product demand, okay, in your product demand, what are the impact that received from your product demand price? Okay, either it is decreased or increased. Okay, maybe in a beauty company, say Fair and Lovely or any beauty company, you will do start have that product and will do some experiment to get that data. Okay, so as a actively you are participating some experiment, actively you are doing some intent to receive some data. That is nothing but your primary source of the experimental data or the experimental study of your data. This is one part of our primary source. Okay. An important thing is I am providing the exact stimulus and then observing that exact behavior that we receive. Okay. Then you collect. This is the main important. And in the primary data source, there is one is our nothing but non-experiment. You know, as experiment, you can see non-experiment. Okay, in this non-experimental data, where you will be not actively participating, but nothing but you will observing some behaviors. Clear? Suppose in your example of customer care, okay, you are not doing the customer care, but you will be received that at exact 10 customer care of the Airtel in the 10 exact big city from the India. What are the how many types of call you will be receiving? So you are nothing but observing from some other people's perspective. Okay, but for you still have that exact intention in your mind. You know that what you will do. That's why it comes in your primary data set. Okay. where the data you are not providing the stimulus, but some other stimulus you will be receiving, some other stimulus already have, and you are nothing but observing from their behavior. Okay, and you collect the data. This is comes considered non-experimental data, or maybe observational data. Okay. Sometimes one really good example is this one, the demonetization. Yeah. In that demonetization back in 2016, okay, you may be collecting the data of the demonetization. So you have the exact stimulus, but you are not providing it. The government did the demonetization. You are just collecting that how many people are in queue of an ATM line. Okay. So it's kind of behavioral under where you are not the as a primary aspect, but you are doing the taking the primary data. Okay. And last part you can say you already know there is nothing but the survey. Okay. Survey is in the survey you don't know the stimulus. Okay. The proper proposition you don't know. In that survey, when you give that entire maybe some leaflet or some form to get that received by the survey, and from that point you will be creating some stimulus. Clear? Maybe some Q&A part. Okay. Maybe you want to ask the customer about the product they will be using. Okay. So you may create some product behavior statistic there. So survey where nothing is not the data will be not the data people will observe or people will create receive from their imitative, not that my stimulus and I am giving and I am performing the exact same examination. Survey is nothing but we are just some kind of basic uh, asking question we will do and we'll collect the data. Okay. As I am the primary source of doing it, so it comes along inside our primary source of data. Okay. Now, in the secondary part of the data, okay, in this secondary part of our data, first comes is one is internal. Okay, internal as I say, suppose sales data. Okay, suppose employee details. Suppose your student details in a school. Okay, maybe some customer data of a telecom industry. You were just collecting those data from their some purposes. You were just collecting those data. Okay. Now, this data is nothing but we are collecting internal from their side. That's why it's called as internal data. Maybe in that external is nothing but some maybe you collected some source from that survey, and not the survey, some public sources like say when Indian government do the budget trend after post 6 months or the 8 months of the budget, the entire government expenditure already published through their website. So you were nothing but just collected all those data for your some kind of other purposes, maybe some kind of government related scenario you will do, and you collected those data. Okay. Maybe some other resources you will collect it. That's why those called are external. Okay. Most of the time you will we do either using the external data or maybe using the internal data. Okay. So in our daily work, most of the time is the data will be received is nothing but a secondary source. Okay, either is an house price regression. Okay, from this house price regression, we get that idea of the business requirement. Then we get that idea, we get that data either it's an internal, or external one. That's why it came under the bigger picture of your secondary data source. Clear? This is based on the sources. Okay. Now, in this AI, this internal and the external, there is other kind of data like your discrete data, continuous data. Those also can be covered based on the types of the data you will be receiving. So that's why the purpose is always mainly matter, because the based on the sources that I am differentiating into this two category. Okay. Now let's create one type of data is nothing but our say based on the time. Okay. Maybe some time series data. So based on the time, okay, this right, based on the so based on the time period or maybe time references, we can create two types of data. One is our the contingency table, okay, or maybe cross-sectional data, cross-sectional data, and cross-sectional data is nothing but when it's stored in the contingency table, this cross-sectional data. Where suppose in this example is suppose you were collecting the data of HDFC Bank, where at that same time, say suppose 10 a.m. or 11 a.m. at all branches in Mumbai. Okay. So from each and every cross section, you were collecting a particular timeline of a data. So that can be stored in a contingency table. This is nothing but your cross sectional data. Okay. And another data is your time series data or longitudinal data. Okay. Longitudinal data or maybe time series data. Okay. As from the name, you can say that this time series data is nothing but say suppose at that 11 a.m. Number of people is going from as different days in every month in a single year of HDFC. Okay. Maybe in this January month, you are collecting the data of how many people are stacking at 11 a.m. in an HDFC branch of Saltpet. Okay. So the exact 7-11 a.m. of entire month. So those data are considered when the types on the exact scenario is nothing but the collected for a several time period. So this comes also inside our time series data. Okay. And your
Hello, sir.
processor, yes.
স্যার এটা একটু রিপিট করবেন এই টাইম পিরিয়ডের উপর যেটা বেস্ট করে দুটো ভাগ করলেন?
Okay. So in this cross-sectional data is nothing but when we are collecting at the same point of time. Okay. So exactly the same point of time when we are collecting the multiple data. And in an example, as I said you that at 11 a.m. that every single branches in Kolkata, how many people are visiting. Okay, we just collected those data. So at the same point, we are collecting the multiple data. This is nothing but your cross-sectional data. And from a time series data is nothing but when you are collected over a several time periods. Say I am collecting for 10 a.m. At the 10 a.m. how many people are visiting in this HDFC branch of Salt Lake, okay, for over a month. So you are collected the data for a several time period. That comes under the picture of your longitudinal or the time series data. Clear?
Yes, sir.
Okay. So this is basically based on the time period. Now let's say next we can consider is our values. Okay, based on the types or types of values or the value, based on the values we can create what the major data which will comes under the quality data and the quantity data. Based on the types of values, we can create multiple category. One is simple, nothing but a numerical category, as you already know. We can also create as a category. Say one is numerical category and another point is our categorical category. Clear? Or you can call you as a quantitative data or the qualitative data. Okay. Now, numerical category, as you can know, we can also differentiate into two major categories. One is nothing but our say
Continuous.
yes. One is discrete data
On
first, and another is one continuous data. Okay. Distinct. The major properties, as people know, that data should be distinct. Okay. If data should be distinct, otherwise if there is a mismatch or some continuous abbreviation, then definitely it will not consider under our discrete data. Data should be distinct, and its means distinct is nothing but it should be independent from a single event. If I call you in terms of the probability, from a single event, it should be independent to the compared to all those events will be done. At that same point, if I toss a coin, it will came at the head. It will not does not depend of it does not depend to the more 1,000 or 2,000 times we will toss a coin. Okay, it is distinct and it is independent. Maybe there one good example is, if you see there are many sections in a class. Okay, suppose in 5 there are 4 sections or 5 sections. Now you are measuring the progress of a class, come and try to compare with the other class. So the progress of a class is not dependent to each and everything. It should be independent. Okay, if some classes already finish 90% of the data, some or 90% of the syllabus, some section may finish 80% of the syllabus. It does not depend on each and every part of the other sections. So all those data are distinct and independent. Okay, and there should be independent separate. Yeah. Suppose those, there are many examples. There is no end if I start giving the example. And in this continuous part, there is the interest. Okay. In this continuous data is nothing but a measurement. Most of the time, continuous data is nothing but our measurements. Okay. Suppose you were measuring same data. If I give you the example, this is really the beauty of equal strategy. The same example, how many types you will represent. In the discrete data, I am representing a progress of a section, progress of a section for the entire syllabus. Either section A already finished 90% of the syllabus, or section B may finish 80% of the syllabus. Section C may finish 70% or maybe 85% of the syllabus. Okay, so it's not it is completely separate, completely distinct to each and every one. Now in the continuous part, I am measuring in every week. I am asking about how many progress it will finish. Maybe section A finish in a week is first 15% of its syllabus. Maybe in the next week it will finish 20% of its syllabus. Okay, so it's nothing but we are counting the measurements of an entire syllabus, how many percentage it will be finished within a single week. Okay, so it's nothing but the continuous data. Or maybe more simple, if I ask you, suppose height of it. Yeah, right. At age 5, what is your height? At age 8, what is your height? At age 9, what is your height? Kind of. Okay. So those kind of picture, when we start doing the measurements, it will definitely comes inside our continuous parts. Here. Maybe some marble weight, maybe some pressure in the vapor pressure in the different planet in our entire solar system. So it is nothing but our comes inside our measurement scale. Now, as continuous the measurement scale, this measurement scale, we can also create. Okay, before finishing, we need to finish the categorical part. Categorical is nothing but will come again. Means from the based on this measurement, and we can, from the types of scales and the types of scales, we can divided this category into two parts. But better if we, some people also do there by the your nominal scale and the ordinal scales, but it's better if we write that based on our measurement scale we will do this differentiation. Okay, so I'm not differentiating here, I am just create the types here, so where I will write based on measurements. Clear? So based on measurements, same things, we can either create the qualitative data and some quantitative data. Okay, qualitative data is nothing but our in the based on this categorical values. Okay, where qualitative data we can divide it into two categories, and similarly the quantitative data we can divide it into two categories. Now here comes the interesting part. Interesting means this is where we'll start creating the relative ideas. In this case, first qualitative data is nothing but our nominal values. Okay. So based on the types of values, we can create the nominal as a discrete and the continuous. Here, based on this measurement value, we can also create the nominal and ordinal. It is nothing but our scales. Now, and based on this, this is on the qualitative part, and the quantitative part we can create. There is a two option. One is our interval option. Okay, and these are ratio scale. Okay. Now interesting. Now see how this each and every part are be similar and the related. Okay. In this nominal part, now what is the nominal data? Nominal data is nothing but a categories. Okay, so a categories where it has no meanings. Okay, it is nothing but a discrete and unique. Say most of the time, what is the gender? Either it's a male or female. Okay, maybe suppose people ask you how many languages you will speak. You can say I speak Hindi, Bengali, and English. Okay, can you order it accordingly? I believe no. So it has no meanings, nothing but we can just discretely created some categories. Okay, so most of the time you cannot choose the orders. Okay, you can just place it in different categories. Okay, you can do some other example like in your after finishing your 10th studies, there will be some people goes into arts, some people goes into science, and some other people goes into commerce. Okay, can you categorize it? I believe no. So you cannot categorize in the nominal scale value, but it has some category understanding, some levels. It basically has some levels. Okay, and it should be discrete. There should be no yeah, overlap of the data. You cannot order the data. Okay. Okay. Simply like category. Okay. And when you have only do the binary values of data, it's called dictonomous. This is the one term, the namology the people can ask. Dictonomous. This is a nominal one. If like some gender related question, are you married? If you yes, then you will write why. If you are not, then you will write no. So this comes under the bigger picture of your nominal value, where a simple category has a single meaning. You can have a basic understanding, but you can only do the categorize, but you cannot order it. Okay. Now in ordinal scale is nothing but it will be counted some nominal, what is the property the nominal value will produce plus an extra properties. I will put it. Ordinal is nothing but the nominal value, nominal properties it will provided already, and there one new additional property added. What is order? So you can now order your data. Okay, order in sense from data has now already the properties you already had from the nominal scale. Now you can rank your data. You can rank means a basic meaningful understanding of the data. So suppose you were doing graduation, then your masters, then your research PhD, then your postdoc. So postdoc people, you can from a basic understanding you can see that those people have the more knowledgeable people that they are doing postdoc rather than the basic graduated people. So you can rank them. You can rank them basically. Okay. Maybe you can say that if you start ranking, then classes in a school, say fifth class and the sixth class or the seventh class. Okay. Those kind of things. You can do basic, not the differences, but some basic understanding of in a scale, like if it has some meanings or doesn't. Okay, those kind of things. Maybe experienced people, you can see that 6-year experienced people has a more knowledgeable than a 3-year experienced people. Okay, you can rank it, the major properties you can rank it based on this nominal scale, and all those properties that the nominal people have will also follow here. Okay. Next will cause it will came is our interval scale. Okay. Interval scale is nothing but all those properties that it follows. Say all those properties of nominal and the ordinal will follow. And in this interval scale, we will do is I will better write here nominal plus rank plus you can measure basic differences. Okay, basic difference means you can positively or negatively measure the differences in this interval scale. Okay, so interval scale has all those properties of the ordinal data and also measure the basic differences between peoples. But yeah, in your interval data has only an arbitrary zero. Arbitrary zero means suppose you are measuring temperature. Okay, you are measuring temperature of say suppose one hot water has 80 degrees Celsius and another hot water has 100 degrees Celsius. So you can basically tell is that these two the content pot two water is uh, 20 degree more hotter. ঠিক আছে? But if you ask a simple question that if you add these two water into one pot, is it increase the total temperature of 180 degree? Yes or no? If I ask you that one pot has an 80 degree Celsius or 80 Celsius temperature of water, and another pot has 100 watt. If you add this two pot, is your temperature will be 180 degree centigrade?
Sir, no, sir. They will
No, sir.
balance.
No,
They
sir.
will balance.
So then the major difference is the absolute zero, because in the interval scale there is no absolute zero. Okay, no absolute zero. We can only measure the based on the Celsius scale. We can do the comparison, right? Maybe the Kelvin scale will be different. Clear? Maybe in the Fahrenheit scale it will be different. It will represent the same meaning, I believe not, but you can only tell that yes, this content pot 2 is a lot more higher temperature than pot 1. That only that one conclusion you can do, but you cannot tell that it's an 20 more times more Celsius or 20 times more increasing than this pot 1, because we are not calculating from that absolute zero. Absolute zero is not exist in this internal data. Okay, so one of the good properties, no absolute, right, no absolute zero. Clear? So suppose there is one good example is you are measuring the longitude and the latitude. Okay, suppose if Delhi has some longitude and latitude and Mumbai has some longitude and latitude. So can you tell that Mumbai is higher and Delhi is lower, or Delhi is higher and the Mumbai is lower? Because we are measuring the longitude and the latitude scale based on the Greenwich Midland, right? In the equator position, from there when we create all those degree points, then only we can tell you that yes, Mumbai is higher and the Delhi is lower. But if we change that equator, if the equator point is changed to the GM1, GML, which is Greenwich Midland, then definitely it will change. Maybe Delhi will become higher and Mumbai will become lower. Who knows? So we cannot do that absolute zero. We cannot do exact prediction of this is that much higher or that much lower. Okay. So there is no absolute zero, no true zero. So we cannot compare it. In the simple sentence, we cannot compare it. We can just create one basic conclusion like this one is that and this one is what. Okay. Those kind of properties came under the interval, because these two properties, the interval and ratio, people will definitely confuse, because these two properties are so similar that one single key difference is the no absolute zero. Okay. Now, say even if I ask you that one people born like you born 1999 and some people born is 2005. Okay. Now from that scale, you are telling me that I am 5 years older than him. Clear? Now, as that from where the time is came nothing but after that this 19 series this series counted after Jesus. Okay, be after Christ, that's people start scaling. So if there is some other scale, there will be some other representation. Okay, you can only tell you that represented as I am older. Okay, so only based on that scale you can telling you that I am 5 years older than him. If the scale is changed, then there is no proper definition of you are exactly 5 times or 5 years. Clear? In that ratio scale, that confusion we can clear is in that ratio scale we can easily start the conclusion based on the absolute zero, based on the true zero. So all those properties that interval scale has. Okay, resume I will write nominal plus rank plus say your ratio scale, or maybe measure the difference, plus we can get is a absolute zero. Okay, or true zero. absolute or zero. This is nothing but represent your ratio scale. Okay. Now on that ratio scale, you can tell that if something is how many times higher or lower or younger and older, the difference. Okay. So that time all your data in here based on that scale, you can only do some positive or negative impact in this interval scale. In the ratio scales, you can do all kind of arithmetic operations. Clear? All kind of arithmetic. Either you can definitely do the multiplication, division. Okay, all kind of arithmetic operation you can do in the based on the ratio scale. Because I am in this ratio scale, say from that height. Okay, from that height, you can say if I am 2 times taller than him or I am 1.5 smaller than him. Okay. Now, this is where this confusion came because as internal, when I am not able to compare these two because I am representing, because these things is differences came in the representation. If I same things I talk in this internal scenario where I will say, okay, in your suppose in your meter scale, you can do is I am consider that you are 1.5 meter taller than me. Okay, in this interval scenario, but in this ratio scenario, when we will represent I am 1.2 times taller than you, or I am 1.5 taller than you. Okay, same example is from this Greenwich midline or what we can easily tell you that you can compare that either if Delhi's position is 1.5 times higher than this Gurgaon, or maybe Delhi is 2.5 times higher than this Mumbai. Clear? Before previously we do this all those arithmetic operation of positive and the negative based on this one scale, like some kind of arbitrary zero. Here we have the true zero. So whatever scales you will have, you change that scale, but your value won't change. Okay, that scenario came answer the ratio scale. Okay, so in the end, the interval ratio is nothing but in which types of measurement scales you will represent it in. Okay, the same scale you can represent the internal scale, same scale you can represent the ratio scale. Okay, based on this which scale you are representing, that's the only matters between those two, and that's the only difference. Either you are based on your true zero or based on the absolute zero. Clear? Not the true zero, based on the arbitrary zero. This is the arbitrary zero. I'll better write arbitrary, not the absolute. Based on the arbitrary zero, we will be scaling and here based on this true zero. Clear? So this is the major difference because this interval and the ratio, the major difference, people became confused. Okay. What is the exact? As I the same thing. You can like if I give you some good properties. Yeah. If I give you the good properties, in your interval and in your ratio scale, in the interval, you can only feel the difference. You can only feel the difference. Clear? But in this ratio scale, you can actually measure the difference. Clear? In this interval scale, like you can basic do the addition as a basic subtract the value or addition that value to get some kind of picture. Okay. Basic normal differences, but in the ratio scale, you can get that proper difference. Okay. You get the proper difference. Like you cannot tell like if I have 50 degrees Celsius plus 50 degrees Celsius, you cannot say this is a became a 100 degrees Celsius of water, okay, or 100 degrees Celsius of mass. But in that ratio, when you do the scaling, you can add 2 kg of mass, okay, 2 kg of mass of say suppose wheat grain, and again add 2 kg of mass of wheat grain, so you can get 4 kg of wheat grain. Okay, this is nothing but how we represent the data. Okay, on that scale, how we represent. And from that representation, you will do the computing. Sometimes maybe you may not need to represent in the ratio scale rather than the interval scale will finally work. So your model may not be required a ratio scale. So model complexity become much lesser. Okay, your model become more easier. Sometimes for improvising the accuracy, you improve those data points and you convert into the ratio scale, and then you will do this modeling and you'll get the much better accuracy. Okay, so this is how we in general the internal scale and the ratio scale is work. Um, okay, the interval and the ratio. If we start the central tendency, then it will take more time. Maybe next sessions will discuss. Okay. Now, before I finish today's session, let's do one example. So understand that how much you will understanding that. Suppose in an example, if I ask you, okay, say one data point has suppose some name of employees. Okay, some name of the employees have. Okay. Say name is suppose A, B, C, D, X, Y. Can you tell me in which data category it will represent? In this out of 4, okay, nominal, ordinal, uh, interval, and this ratio. In this out of 4 scale, which category it will represent? You can tell, otherwise,
Sir, just only the name of the employees.
just run the name of the employee. And where are the other people? Only single people is speaking.
Nominal.
Yes,
Sir,
this is
nominal.
nominal. Yes, this is nothing in the simply comes in the nominal category because you can only categories. Okay, you can only do the categories. Like if one person represent one category, this person represent his own category. Okay, if this person is repeated, then it nothing but comes under this his own category. Okay, so nothing but your nominal category. Now, if I ask you, suppose say employee and employee code. Okay, say employee code something like 11023 11019. Let's say 11001. Now you tell me in which category it will be considering.
Sir, ordinal.
Why ordinal?
Sir, with name also there are extra added the employee code.
Yes, added code.
So different types of code for different employee.
Different types of code for different. Yes, that's much clear. But what we know from the ordinal scale is we can rank them. Na? In this ordinal scale, Can
Yes,
you
sir.
tell me that this employee code has much experience than this employee code?
No, sir.
Then, so maybe these people is maybe 1019 is nothing but a junior level developer. Okay, this employee is nothing but the CEO change, a new CEO joined, and these people is the new CEO. So definitely CEO has a lot more experience than this one. So can we rank them? Definitely no. So it is nothing but our simple nominal category, simple categorical data. Clear?
Yes, sir. So that
Mhm.
means ordinal category, if we should put them in ordinal category, then we require some proper descriptive or proper.
Description. Yes,
Yes, sir.
proper description. Because only but just seeing this data is nothing but it comes under our nominal one. Okay, we cannot rank them. We can simply categorize them because maybe I don't know in what is the purpose of this table. Maybe this employee code repeated here many more times, and you will say that this is same as similar to the name. It will comes under his own category. Here now there is one is called gender. Okay, suppose gender male, female, male, others. Can you tell me which in which category it will be representing?
The nominal, I think.
The nominal.
It's again came inside a nominal category.
Nominal.
Right. Now gender done. Then you can do one good. Suppose date of birth. Yeah. Some date of birth say 14/7/1991. Say 22/8/2001. Okay. Maybe one older in 1988. Now this category, I already gave one example. Most of the example will be coming inside this four category. You do not have to think about no, this is a time series data. No, just simple in your nominal scale, either the ordinal scale, interval, or ratio scale. In this four scale.
So ordinal.
Anyone? Anything else?
Sir, interval.
Interval. Other people?
The ratio.
Yes.
Sir, for the scenario of age seniority, they need to put on ordinal.
Ordinal. Yes, it will come ordinal, but you missed one more thing. That you can also tell that basic difference. Okay, you can measure the difference that this guy is maybe 10-year older, this guy is 12-year older, this guy is 10-year younger, right? So you can ordinal plus you can do the major difference, but you cannot, as I told you, the time is only came after the death of Jesus Christ, right? From that point of view, that time started counting. Before that, the other measurement were there, the before birth and all. So you can rank them, you can measure the basic difference, but you cannot have the true difference. Okay, so you can tell it's an interval category. There, it comes inside our interval, yeah, interval scale. So always remember in this interval scale, we can measure the difference. Okay, but measure definitely based on an arbitrary zero. I am measuring based on that date, which is nothing but depends. Maybe if there's some other scale we can represent, then the value will be changed, right? If Jesus was, the concept of 1991 after the Jesus was not there, maybe some other scale it will be start measuring. Then is that value will be represent the exact same difference than other part? Means on I'm giving a really better example. Suppose before the other calendar like Maya calendar, even in that Bengali, there is a two term called the Sokabdo and the Bongabdo. If you know the history about the Bengal and other people, from that king of empire, the King Sasanka, who established the from that Bongabdo concept to the Sokabdo, and the new measurements start building. The current Bengali calendar you guys see now, what is called that the current is 1328 or 1329. That value is came after this exact king started building this Bengali calendar. Before that, there is some other issue. So is you can tell that this guy is 10 years older based on this scale. Clear? But in if we consider in this Bengali scale, okay, in this Bengali calendar scale, the value will be 15. Clear? Maybe value will be can we say that the value will be different? So you can measure the difference based on the source scale, but you cannot compare it. You cannot exactly compare it that yes, this guy is 10 times or 15 times more older, more younger than me, because I'm only based on a one scale. I can do the measure the difference. Clear?
Yes, sir.
This is important because only this part people will really get confused in this interval and this ratio scale. Okay. Similarly, if I give you example like suppose the education. Okay. Suppose as these people is older, so suppose he is postdoc, PD. This people is MBA. Okay. This people is graduate. So from that point of view, you can easily tell that it's a nothing but our ordinal category, because you can rank them based on this. Like postdoc is has a much higher experience and the much knowledgeable person than a basic graduation. Yeah, the basic order you can rank them. That's why it's come considered ordinal category. Okay. Similarly, like the date of birth or the date of joining, you know that time is nothing but most of the time is interval category. Clear? Similarly, yes, one more thing is this. Suppose designation. Okay. This person is CEO. This person is BA. This person is suppose ADS, Associate Decision Scientist. Okay. Now tell me in which category it will come.
Ordinal.
Yes, it will come as the ordinal.
Rank wise.
You can only create the rank. And last, say suppose salary. Someone received 65,001. Someone received 89,023 rupees. Someone receiving, say suppose 79,021. Now, can salary came under that each category of this based on this measurement, like nominal scale or the ordinal scale or the interval scale or the ratio scale? Because as salary is nothing but most of the time the discrete value, we can just simply call it as a discrete numeric data. This one category can tell you it's better not to represent based on the scale, because there is, if you start doing the category, it will hurt that each one represented a single category. Okay, so most of the time we can in the salary we can measure the difference, you can do all those kind of things. It's nothing but a discrete data. Clear? So
Salary can be ratio value also.
salary can be ratio value, you can compare that also. Salary can be also ratio value.
Yes.
It's in the end, the main motto is our that train the model and get the performance. So based on it, you do from this discrete value, you can just do the discrete. Okay, even as you do the one good example, I can say one more thing is this salary, if we start take one base value. Okay, if this is a 69,000, suppose in CEO salary is 1.5 CR. Okay, and the junior developer salary is say 15,000. Clear. Now, if I start training our model based on this data, look at the difference from 1.5 CR, not 1.5, one more. 1.5 CR and one people is 15,000. Look at the difference. So if we just train your model with that difference, this is definitely change your accuracy of your model, because the computation will be really high, no? And not on a single data, there will be much more of it. So definitely there is a one good option is you scale the data. Okay. As from our today's learning, we can simply scale the data in a ratio scale. Okay, where we can compare, we can took one base salary, just compare or take a base salary, and from the base salary it is how many times, either it's a 1.7 or it is a 9.8 times higher, and we can then put that model so it will get the better accuracy, then just rawly input the data. Understand? So that's how we changes each and everything. Okay, no issues. So finish everything until the today, the types of data. The next day we will start discussing about the central, that's exactly the central tendency and the dispersion of the data and the basic statistical measurements. Okay, and the if we have the time the next session, then we will start talking about the basic probability density functions. Okay, then I'm finishing here for today. If you guys have any question, you can ask, or else we'll meet in the next sessions.
Sir, when our next class?